With the quick advancement of technology, there have been vast improvements in the world of robotics. We take you into the University of Minnesota's Lab of Distributed Robotics, where a life-saving robot was built. Talk to those who use it and find out why robots are crucial today and in our near future. I'm Rana Kamal. Our Issues Twin Cities starts now.
Here you see one with threads. Why? Because these legs are not very effective for long distances.
Okay.
You see, you don't want just...
And it's slower.
And it's very slow.
At the University of Minnesota, some of the most inventive robots were created in the Lab of Distributed Robotics. Professor Nikos is the brain behind the cutting-edge technology.
We do a lot of stuff, and we dream a lot. So this is the exciting part of the job, that we dream systems that fly, systems that swim, systems that they can fly and they can swim, or they can move on the ground. So we try to push the envelope of the technology in a way that we can have something that can impact lives in some profound ways. And this is the objective. So when someone tells us it cannot be done, this is the springboard for us to try to say, okay, let's prove them wrong.
The University of Minnesota's Lab of Distributed Robotics started in the 90s. Today, they are at the forefront of research in robotics, with nearly 100 robots in the lab of varying sizes.
The center started more than a decade ago when we got a large grant from the Department of Defense in order to develop the smallest yet functional robot for surveillance and search and rescue. And so we developed the Scout, and the Scout attracted a lot of attention. And then we had to have a center in order to have all these different disciplines under the same roof and have the exchange of ideas. And the center evolved, of course, throughout the years. So initially we were heavily focused on hardware, but now we're doing more and more image processing, computer vision, and sensing. So we're changing.
How do you guys come up with the ideas? How do you design and develop the robotics?
The trick is to have the right people. So the students are the generators of ideas. So my job is to hire the brightest, the most creative kids, the kids that have no fear of failing, and then you let them loose. I mean, you give them enough freedom and enough, and they are going to come back with just small miracles.
As the enablers, the students are very essential to the lab. More than 80 students have graduated from the center and hold influential positions in the industry.
It's really great that you can combine the mechanical aspects with the electronics and then programming to make something that moves and does whatever you program it to do.
What are you guys looking forward in terms of the future of robotics?
I am mostly working with agriculture projects.
Okay.
So I would love to see a fully automated system for cultivating agricultural products. This would include some sensors that are fully connected and communicate, as well as robotic platforms, both aerial and land, that also communicate and provide the best possible information to the farmer.
When it comes to imagination, the sky's the limit for these students as they create and develop robotics.
We do a lot in the lab. We have some ground-based robots, we have some water-based robots, some aero robots. You know, like this guy, it's a Scout robot. He's very robust. You can throw him, you can throw him off airplanes, off of UAVs that we have in the lab. But on the other side, we also have robots that can go on the water. Like this one I've been working on, the aquapod robot. And with this one, you can actually program it to go to a certain depth and have it come back up or collect a water sample so that a researcher can play with it or analyze it in the lab.
This is the interesting aspect of this job, that we can do a lot of this stuff. and the students are the enablers.
What robots have emerged through the center?
There is a variety of robots we have developed. So the first one was the Scout. Scout is a ground platform. In other words, it moves on the ground.
Okay.
So the next thing is actually let's make something that can move better on the ground.
Okay.
And then we develop the Adelopod.
Okay.
And then we develop a version that can swim, that is the Aquapod. Then we develop an educational version that we call the eRosi.
Okay.
And then we develop a hybrid platform that can fly and can move on the ground. It's like a transformer robot. And then we move on teams of robots and having a lot of them of different sizes. And then we had this great student, Sam Hebert, who wanted to have the mothership robot. In other words, a robot that is going to deploy the little robots.
Okay.
So we got the Loper.
Okay.
And then we develop something that's called the Mega Scout. And the most recent stuff is a flying robot that uses solar energy in order to charge its batteries and fly 24 hours a day for a number of applications, including inspection of corn fields for nitrogen and reconnaissance, surveillance. So we are, anywhere there is a good idea, we try to pursue it. Many times we fail, but a few times also we succeed.
Coming up on Our Issues Twin Cities.
I'll take a look here. I've heard, but I want to see it with my own eyes here, and I brought it to our training session of our SWAT team, and we started using it and figured out it could be an important piece of equipment for us to use.
The robot that saves lives.
We went to a bar just to feel a little bit better about our failure. And we talk about a robot that resembles a pickle.
Okay.
Because a pickle has the shape that is really portable, it's very easy to carry. And then I talked to a Marine who told me, look, if you want me to carry this, make it small. If I have to take and make it light, if you want me to carry it, you have to make it light, and this has to save my life.
The robot that resembles the body shape of a pickle caught the eyes of many around the nation and all over the world.
The Scout, it was one of the largest deployments of robotic devices in the world. There are more than 4,600 of them used by the armed forces, by police forces, by prison systems. Sometimes we see them on TV used to deal with search and rescue. So something that started as an idea on a piece of paper is really gratifying to see it being a system that saves lives.
When Patrol Sergeant Chris Kuklok first heard word about the Scout, it immediately piqued his interest.
I personally found out about it and did some follow-up with the company and said, you know what, I'll take a look here. I've heard, but I want to see it with my own eyes here, and I brought it to our training session of our SWAT team, and we started using it and figured out it could be an important piece of equipment for us to use.
And in 2010, Plymouth Police Department began to use the Scout. Why the Scout in particular amongst other gadgets or robotics?
Scout for us met a lot of criteria that we were going to use it for in the tactical world.
Okay.
Right? It had to be simple to use, durable, and flexible. Sometimes robotics can be very complicated, and that can make some people a little bit leery about using it, particularly in law enforcement. We can't have things breaking down, have them be really complex. So once we realized we started using it and seeing how we could deploy it with us and the SWAT team, it started to become apparent that the Scout anyway checked all those boxes for us.
Casey is one of Nico's former students.
The definition of robot is a little bit difficult to tie down. To me, it is a device that senses the world around it, learns from that, uses that information then to make a decision based on preset a preset set of instructions, and then uses that information to affect change in the world around it.
Casey is an engineer at Nextern, a domestic and international manufacturing company where the Scout was first built.
It wasn't a fully developed system. It needed some tweaking to become really truly manufacturable. So there was a lot of work getting all the tolerances down, getting all the materials figured out, getting all the programming and the code correct, and getting everything really settled into a way that it could be mass manufactured. So there was a lot of late nights and a lot of really burning the candles at both ends to get it up to that point. There were very early customer needs that people wanted this robot, and so we had to do everything we could to really make a quality product.
Today, Recon Robotics is the sole manufacturer of the Scout, distributing to more than 35 countries worldwide.
I actually started at the University of Minnesota in 2006, and a couple students and the professor developed the robot using DARPA funds for the military. And they saw that they had a useful tool, and it spun off into a company, Recon Robotics.
Today, you guys are the second largest producers of military and police robotics in the world, distributing now to over 35 countries. What does that mean to you guys?
It's rewarding when you hear the stories from the military or law enforcement on how the robots save lives. It makes you come into work every day and have a sense of pride what you're doing.
And how has it been beneficial?
We've used it on a few scenarios that meet the criteria for its use, and that is usually a situation where we have a house or a structure that's not been cleared, and there's potential for someone to be inside, possibly armed or confirmed armed, and if we have the time to do so and the luxury, we will use the robot to help make our entry a little bit safer. It can go in through windows or doors and so forth, and we'll drive it around to kind of see the lay of the land a little bit before we actually send people inside. So it makes it a lot safer for us. We can get a little set of eyes inside there before we actually make entry.
Are there any challenges that you guys have faced when you use the Scout, or any negatives?
Oh yeah, every piece of equipment you have has limitations. Obviously the Scout can't open doors. It can't be driven upstairs. You can drive it downstairs, but you have to toss it up. So, and it has a battery life issue that if you can use it for an extended period of time, you have to consider that in your operation. It's easily rechargeable, but you have to kind of plan ahead a little bit with that, and so forth.
What makes it stand out amongst other robotics?
Weighs 1.2 pounds. It's extremely rugged. It can withstand a 3-story drop onto concrete. It's made of titanium, has infrared, can go over 2 to 4 inches. You get live feedback from the robot to a handheld controller, and you can also record and take snapshots from the Scout to a command post.
And it's this pickle-inspired robot that has come a long way today.
And we try to make it as effective as possible. So this carries a camera. It has the trigger, inspired by the way that the armed forces are using it. And here is the controller, and you can see where you go. And I can increase, by using this device, I can increase the distance between the human and the harm's way.
Up next on Our Issues Twin Cities, the many ways robotics are beneficial today and in our near future. At the University of Minnesota's Lab of Distributed Robotics, Nikos and his students continue to push the envelope and work on new, innovative technology. What robot to date has been the most important robot that you guys have created?
The solar UAV. UAV stands for Unmanned Aerial Vehicle. So it's a small fixed-wing plane, very small, that is portable. So we don't have, that can fly continuously with no interruption. And I think this is where you are pushing the envelope of aeronautics, aeronautical design, controls, embedded systems, sensing. Think of a fixed-wing plane that is full of solar cells. So imagine that we have solar cells here. So we use these solar cells in order to charge the batteries, and this plane can fly 24 hours for days.
More and more robotics are becoming a part of our everyday lives. Many companies around the nation have or will use robotics at some point in the near future. Some people call robotics job killing. What do you think?
Robotics used to be job killers more in the past. I think we are seeing, and I will mention some examples to substantiate this. We're seeing robots being job enablers. These are different jobs, but if you take, I'm not going to mention names, there is a major company which is shifting all its production from China to the US. How can they do this? By using robots. Now, these robots need operators. You see, these robots are not autonomous. So we are seeing millions, hundreds of millions, billions of manufacturing coming back to the US.
I think it changes the aspects of what the workforce looks like, right? Instead of having the people who are doing the manual labor tasks, that's where the robots will come in. But then those people will have to learn new skills to be able to work with the robots, right? You got to program the robots, you got to build the robots. If you have to do all the, they can't exist without us. So it changes the workforce.
How are robotics more important today than they've ever been before?
Robotics are becoming more and more relevant. 10 years, 15 years ago, this was not the case. Robotics was this exotic field that will take 10, 20 humans just moving a robot. It will require a PhD to move a robot from point A to point B. And we have made some great strides in making this accessible to a larger number of people.
They're entering into everything, right? They are, the more and more that humans need assistance and want to get efficiency out of their everyday aspects of life, robots are helping to further the human ability to do things.
We see robots that assist surgeons. Da Vinci is a huge success. For example, prostate cancer. The Da Vinci robot has changed the way that prostate cancer is being treated.
After being approved by the FDA in 2000, the Da Vinci was created to enable surgeons to operate with enhanced vision, precision, and control. Today, the sophisticated robot operates in hospitals worldwide.
How essential are robotics to the medical field?
We started with a robot that will assist a surgeon and play the role of a scrub nurse. Scrub nurse is the nurse that handles all the tools that a surgeon needs and hands the tools to the surgeon. So we didn't develop, we designed a robot that can demonstrate some of these basic skills. And then I was approached about how we can make sure that during radiation therapy, we can have control of the system. So when there is movement, basically, if there is movement of the body, we can stop the radiation. So we develop a system to monitor the human body movement. And then we develop sensing techniques for monitoring mental health disorders. And this is something that has been quite successful. It's very important for us, and actually it's taking a lot of the effort. I would say it's more than 60% of what we do these days. Most recently, also we use some of these techniques in order to detect cancerous cells in cases like endometrium cancer or prostate cancer or breast cancer. These are cancers that are very tricky, even for an oncologist. to see the cancerous cells at an early stage.
How do these robotics detect a mental disorder or a cancer?
It's not the traditional robot, it's not a robot but we take the sensor and we take the algorithms that we use in order, for example, to detect the environment or to detect the road or to detect the ground. And we'll try to use similar techniques. So we analyze motion. And in the case of human behaviors, motion is one of the most important cues that we can use. So we try to see, do I move, for example, if we observe a child in a classroom, how does this kid move? What types of interactions does he or she have with other children? So if little Mary is not interacting in a meaningful way with other kids, or if he's only interacting with the teachers, this is important information.
So what's the future of robotics?
Sky is the limit. I mean, as long as we can manage the other side of the coin that I mentioned, I think you're going to see systems in our cars, in our hospitals, in our homes.
Robotics will be part of our lives and will be accessible by us in ways that we can't even imagine yet, right? Like I kind of talked about, people think of robots as those things that come along with us and walk around and can talk to us and whatnot, but it'll really be in our devices. And we'll be able to communicate with those devices and have them do things for us remotely from thousands of miles away, or even just right within our general reach, and they'll communicate with us and be our eyes and ears and our sensors, our helpers.
Probably going to see an increase in its use as the technology gets smaller and drones become, potentially used for search and rescue and that type of stuff. But for us in the SWAT world anyway, it's our go-to piece of equipment every single time we suit up. We have to have that with us. That's one of the things we check and confirm is with before we head out.
Thank you for joining me this week on Our Issues Twin Cities. I'm Brenda Kamal. See you next time.